Welcome back to Urevise, where we talk about everything exams. Okay, let's take a look at question 41B from the 2016 exam. It reads, nitrogen dioxide is toxic to humans when inhaled and is a significant component of air pollution. It can be formed by the combustion of nitrogen in air at high temperatures, first forming nitric oxide and on further oxidation forming nitrogen dioxide. The overall equation for the process is given here. The following questions relate to the equilibrium system represented by this equation. Assuming all the other conditions remain constant, what happens to the equilibrium constant after the pressure of the system is lowered and equilibrium is re-established? Now, usually this question comes with a second part which says give a reason for your answer. Now, according to the examiner, 4,926 candidates attempted question 41 and the mean score was 10.74 out of 18. And they further gone to say many candidates indicated they erroneously thought that K changes with pressure. I know this is one of the things we point out several times, and in school-based assessments, I've seen a fair amount of school-based assessments from teachers that I've done small group moderation partnerships with, and other teachers just sharing resources. You find it's a standard question that teachers always ask. And it's like I said, I usually find that when we ask this question in school, we always, have it as a 2-mark question where students have to explain or give a reason, not explain, give a reason why. Now, the answer to this question is assuming all other conditions remain constant, what happens to the equilibrium constant after the pressure of the system is lowered and equilibrium is re-established. So the answer to this is K stays the same. K stays the same. Now, why is that? Because of this reason here, it's because the only factor that changes the value of K is temperature. Changing concentration, changing pressure, adding a catalyst, increasing surface area does not change the value of K. So if we look at this from a graphical point of view, graphically, let's say I've got this system at equilibrium like this. I'm just gonna put arbitrary values there. Let's say this is nitrogen dioxide and this one here is N2 and this is O2, right? And I lower the pressure. How do we lower the pressure? By increasing the volume. So if I increase the volume, these are going to drop like that, okay? And what will happen is, because I've got 3 moles of gas and 2 here, it means equilibrium will shift this way according to LCP to try and lower the temperature, which means the nitrogen dioxide concentration, partial pressure will drop, while the nitrogen dioxide is going to increase, and this one will also drop. Now, at this new equilibrium, these have changed proportionally, and as a result, if I calculate a Kp or Kc here, Kp1 at this point will be the same as Kp2. If it was Kc1 at this first equilibrium region, which I'm looking at here for all the components, Kc1 will be equal to Kc2 if that was the case. So it's just a simple recall thing that we have to understand, and it's also some of those things where teachers do mention it and students just don't take teachers serious. I'm joking. You guys take us serious, but at the end of the day, you're just gonna have to learn here that if you change concentration, if you add a catalyst to a system at equilibrium, if you increase or decrease surface area or change pressure, that's not going to affect the new value of K after equilibrium is re-established. The value of K stays the same. Now, I'm going to finish off this one here, and I shall see you when you attempt the next question. Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I would love to hear any questions, any concerns, or anything that you think could have been done differently in this video.